Differentiation of trigonometric functions. We'll be looking into the derivative of trigonometric functions. We have 6 basic trigonometric functions. We'll find their derivatives. For a function, say y or f of x, the derivative of y is represented with dy dx. Derivative of f of x is represented with f prime of x. The first is the sine. A derivative of sine is cos. If you have sine x, dy dx is cos x. And if you have cos x, dy dx of cos x is minus sine x. If you have tan x, then the derivative is sec square x. If you have cosec x, then the dy dx is minus cosec x cot x. If you have sec x, then the derivative is sec x times tan x. And finally, if you have cot x, then it's minus cosec square x. These are the 6 derivatives of a trigonometric function. Let's quickly look into the exponential function. Differentiation of exponential functions. We have the functions and the derivatives. Y or f of x. We have the dy dx or f prime of x. The first is the exponential x. If you differentiate exponential x, you have exponential x. If you differentiate exponential u, you have exponential u times du dx. This one means if you have any expression as the power other than x, then you have to take the derivative and multiply it by the exponential u. If you have a raised to the power x, then the derivative is a raised to the power x ln x. Ln x means log to base e. If you have a raised to the power u, the same thing we did here, a raised to the power u ln a times the derivative of u. Let's go to logarithmic function. Differentiation of logarithmic functions. We have the functions and we have the derivative. The first we'll be looking into here is ln x. Ln x, like I told you, is log to base e. If you find the derivative of ln x, you have 1 over x. And if you have a log to any other base other than base e, say log ax, then the derivative is 1 over ln a times x. Okay, with this derivative of these functions, let's solve example. Find the derivative of the following functions. I have these 5 functions. If we solve these 5 functions, then we have touched all the functions I've earlier mentioned: the algebraic function, exponential function, logarithmic function, and trigonometric function. Let's solve solution to the first question. First question is y is equal to 3 sine 4x minus 1. If you take a look at this expression, you have double function here, sine, and you have 4x minus 1. So to solve this, you are going to be using chain rule. So you let u to be 4x minus 1. 4x minus 1, find the derivative with respect to u. Du dx will give you 4. And if u is 4x minus 1, then this expression becomes y is equal to 3 sine u. Then to differentiate this, the y du will be 3 cos u. That will give you 3 cos 4x minus 1. because your u is 4x minus 1. So dy dx finally is the product of the two derivatives, du dx times dy du. If you substitute in their values, you have 4 times 3 cos 4x minus 1. So finally dy dx is 12 cos 4x minus 1. Solution to number 2. F of x is equal to 9x raised to the power 4 plus 7 sine x minus 3 cos x minus ln x. This question contains almost three functions we mentioned. This is algebraic function, this is trigonometric function, and this is logarithmic function. So we find their derivative 10 by 10. So this is f of x, derivative is f prime of x. The power will multiply the coefficient, that will be 4 times 9 x raised to the power 3. You have to subtract 1 from the power. That's how we got this 3. And you differentiate sine to give you cos. You differentiate cos to give you minus sine. You differentiate ln x to give you 1 over x. So simplifying this, you have f prime of x as 36x raised to the power 6 plus 7 cos x plus 3 sine x minus 1 over x. Number 3, y is equal to ln bracket exponential x minus 5x. This is also a chain rule. So you let exponential x minus 5x be u. That will make your du dx exponential x minus 5. Because if you differentiate exponential x, it gives you exponential x. Differentiate minus 5x, you have minus 5. So y becomes ln u, since u is exponential x minus 5x. So y du is 1 over u. Therefore, dy dx is du dx times dy du. The product of the two derivatives we calculated, this and this. So substitute in the formula, you have exponential x minus 5 times 1 over u, and u is exponential x minus 5x. Therefore, dy dx is equal to exponential x minus 5 over exponential x minus 5x. Solution to number 4, y is equal to root x all over cos 2x. This is a rational function, so we're going to use quotient rule. So you let u to be root x, which is also x raised to the power half. Equation 1. Then v becomes cos 2x, equation 2. Now you have to differentiate u with respect to x. It's power half, so bring the power half to multiply x, subtract 1 from the power, that gives us minus half. If you simplify this, you have 1 over 2 root x. So differentiate equation 2, dv dx. You have minus 2 sine 2x. This is chain rule. Differentiate cos, that will give you minus sine. Differentiate 2x, that will give you 2. That is this minus 2 sine 2x. So our quotient rule is v du dx minus u dv dx over v square. Substitute the variables in the formula. You have this.